Hello everyone, today I am here with another video on the topic of machine learning and its application in chemistry. Today I will talk about a Streamlit app that I have built, and the code is available on the GitHub website. The username AW176 is the user account where you can find this repository. App name is the ML model app. So let's open it. Here is the app. In the readme file it is written about how you can use this app for a prediction task. All the requirements and installation procedure is mentioned here. Simply you need Streamlit, scikit-learn, pandas and rdkit, matplotlib along with the numpy and joblib. So installation procedure is you can clone this repository and you can install the requirement.txt file. You can install these libraries and don't need to install if you have already in environment. And what you need to do is to type the streamlit run app.py to run this app. And in this file model ml model app.py you have the code with you, but I will not discuss about this code today. First I will show you the app. So let's run this app in the computer. Okay, now I have to type the streamlit run ml. The name of the file here is ml model app.py. so if app.py is not working, you need to write the name of the file in which the whole streamlit code is written. Okay, let's run it, and in the local browser it is running now. Here is the interface of the app. It says welcome to the app, use smile data to predict the target. So for the prediction task you need to train the model first, and there are two options to provide the file. First, you can provide the file using using the browse files option, or you can use the load data sample. For the time being I do not have any other file. I will use the sample data. So let's load it by checking. You see it says loading solubility data, and here is the data. In the upper right corner it is still running because it is featurizing all the smiles to the descriptors using the backend code. For the time being, let's see what we have in the data. We have case number, smiles and solubility. This app is featurizing smile string into the descriptors using rdkit, where the target property is the solubility mentioned in moles per liter. Okay, let's wait for it to finish after it has featurized everything. In the second part it says data uploaded must contain a smiles and a target column, and the name of the smiles and target column should be mentioned in the next placeholder. And it says enter name of smile column. Here you have to write the smile column name. For example, as it is smiles here, so I have put the smiles here, but your can be smiles entry or something else for the smiles column. And you also need to tell the tell the target column, which is the solubility in my file, which is the solubility in the sample data. So I have written here the solubility. If your target is something else, you can write it here, and the code will automatically extract this name as the target column. Okay, and there is a feature matrix which app has converted using smile, and it contains smiles column and all the descriptors, and these are all rdkit descriptors which the app has used to convert, and these are almost 2000 in numbers. You can review it by yourself later on, and for the time being let's move on. You can close it, and the next part is to develop a ML model. Now we have selected the features from smiles. Now we can develop a ML model. Since this app is not allowing you to use selected features. For example, if I open it, I don't want to use the QED or molecular weight or some heavy atom molecular weight, then I can ignore those features. But this app does not have this provision now, but it is possible to add this provision by just modifying the main backend code, which is available on the GitHub site. So you can do that by yourself, but for the time being I have used all the features which have rdkit converted from the smiles. In the next step I will develop the ML model. So it asks me to select the model. For the time being I have not implemented any other model except RandomForest, so I will use this model. You can modify the backend code and you add your model, such as any linear SVM or any other model that you think may be suitable, and you can modify the app. So additional provision is the selection of hyperparameters. Since I have implemented only the RandomForest, so I have provision of modifying its hyperparameters, and there are two options. Additionally, I can either use the default hyperparameters, which is the option here, or I can select the hyperparameter, which is the option here. So let's see what are the default hyperparameters available within the app. Okay, here are the hyperparameters, and that say the number of estimator are going to be from 10, 100, 500 to 1000, and the bootstrapping and the max step, minimum sample split and the minimum sample leaf, and the max features. If I train the model with these hyperparameters, it is going to take a lot longer, as my laptop is not that great. So I will not use these hyperparameters. I will uncheck this option and I will use the second option. Here in this option I can select the number of parameters I want. For example, I want to select 10 estimators. For the tutorial purpose I will not select any other high-end hyperparameters, as it will take a lot longer. So I will select small options. Okay, let it run. Okay, now is the training part. Now if you are happy with the model selection and all other things, you can start training. The model start to train. As there are a small number of hyperparameters, we have a quick trained model. So best parameters are defined here, and the model performance is given in this data frame, and it says that the R2 square on the training data is 0.97 and the test data is 0.86. so obviously this is not a good model, and we know that it cannot be, because we have not given much hyperparameter space to the model for exploration. So these are the feature importances, and it tells which features are more important for the model during training in terms of prediction, in terms of y column. So let's see what it has to. Okay, these are the parameters that are that model thinks more important for prediction, and the more highest important is the mol log p, and these are the top 10 other parameters. Okay, here is the final part. Now you want to predict the solubility of your data. You can put the smile here. Let's say if I want to predict the solubility of butane, then I will enter the smile here and enter. Model will app will rerun and give me three things. First is the descriptors, 2000 descriptors that rdkit can give of the butane, and here is the structure and the solubility predictions. This predicted solubility of the provided smile is minus 2.55, which is, I am unsure that it is corrected or not. Let's see some example from the internet. I will search for the solubility delineate dataset and see if we can copy some smiles from there, and we can go close to the prediction. Okay, here is the first compound, amygdalin, and its solubility is minus 0.97. Let's okay, here is the smile. Let's copy its smile and put in the app and see the result, that how our model can predict it. And it will not predict it that great because we have not trained it with enough hyperparameter space, although we have given it enough examples. There are 1300 examples. So the value it has given is minus 3.632, and the values was there I guess 0.97. let's see again. Yes, it's minus 0.97, so it's not even that close. Okay, let's try another example, Fan theorem. It has value of minus 2.885. let's copy its smiles here and put in the model. Let's see if it can predict. Okay, the value is minus 2.6. it's not that bad, still we have a direction. Okay, let's go for the citral. We have minus 2.57 value. Let's copy the smile. This is the last smile I will use in this app. You can use your smile or other examples by yourself. Okay, it is predicting minus 2.19, and here we have minus 2.5. okay, that not that bad but not that great either. So you can use this app to predict the solubility, and if you have your own dataset and features, or you don't want to and you only have your smile string and you have different target column, then you can use this app to featurize and to make a model. And in the end, if you are happy with the model, that you are okay with the predictions and everything else, you can export it. And let's check this model. Okay, model exported in CWD. CWD means current working directory. So the place where you will be using this app in your local system, model will be exported to that directory. So the code is available on the GitHub website under the user account name AW1176 with the name ML model app. I have another app here which is Streamlit Chem app. You can run this app too. If you want me to talk on this app, please let me know. Also, I will talk about the code in the next video. Thank you. See you in the next one.